Hello, and welcome to Cisco Data Center Automation with RedHat Ansible demo. I am Mindy Schweitzer, the Director of Marketing for Sterling. We know your time is valuable, so we want to thank you for choosing to spend a portion of your day with Sterling, Red Hat, and Carahsoft. Before we dive into the demo, I wanted to give you a brief overview of Sterling's capabilities. Sterling is a technology solution provider, offering secured, customized solutions for all your client-to-cloud needs. We serve on multiple federal and state and local government contracts and support all industry verticals. Security is extremely important to Sterling. We have a robust, secure supply chain, including OTIPS and CMMC certifications. For any questions during the demo, please put them in the Q&A feature at the bottom of your screen, and we will address them at the end. Now I will turn it over to Cloud Architects Nathan Bennett and Billy Downing to demonstrate the Cisco Data Center Automation with Ansible.
Awesome. Thank you so much, Mindy, for that introduction. I'm Nathan Bennett. I'm the Cloud Architect here at Sterling. Billy will be coming up in just a little bit to take us through the demo. I will be going through a little bit of a overview in terms of the Ansible engine and Ansible Tower, which we will be utilizing in this demo. So in terms of agenda, we're just going to do a bit of an overview, some common use cases, basically a little bit about what is Ansible, how you can use it, and some of the key differentiations between Ansible engine and Ansible Tower. And then we're going to deep dive into this connection with Ansible and Cisco. And then Billy's going to take us through the demonstration, showing us this versatility that you can use with Ansible Tower. So let's jump into Ansible itself. When we look into the Ansible engine, there's a lot of different things that it can do, but let's take a look at what it is and the big things that we can do or that we get by using it. The first one, and this is real easy to point out, which is it's very simple automation. This is a real huge pro for Ansible because their automation tools out there are not really easy to understand, to write, to configure, and to manage. And a lot of times you have to learn another language, or you have to really a lot of places will hire a specific team for that specific automation tool. Just a lot of different complexities. You know, Ansible is human readable. So when you actually look at the modules and the tasks that you're actually writing, you actually can tell what it's actually doing. So it leads to, it removes a lot of that complexity and allows you the versatility to adopt it into your environment. Just because it's simple does not mean that it's not powerful. Ansible is extremely powerful, allowing many different tool sets to become easily accessible to your teams. For instance, you can, have provisioning, you can have configuration, you can have all these different things within that tool set, and you can run them against multiple different endpoints, and that allows you extremely powerful solution for your environment. Going back to that simple side, Ansible is agentless. Myself as an automation engineer for many years, I lived in this deluge of templates that I had to maintain, keep updated, etc. And part of the problem with these templates was you would have to set a particular setting, and then when you converts from a template to being cloned or one thing or the other, agents would break, specific connections wouldn't work, and just many different complexities that made it difficult to adopt an automation tool. Ansible makes it easy by not having an agent and reducing that footprint in terms of solutions that are running on the machine itself, as well as specific agent ports or things of that nature. By going agentless, you can use simple connections through SSH or WinRM in order to connect to these endpoints. Another thing, and this is the way that I myself personally see a real powerful thing in Ansible, is that the modularity that Ansible has. A lot of tools, when we look at um, our automation landscape, really is just kind of this page of information, and it's kind of difficult to dissect the the functions of what it's actually doing. But with Ansible, it actually breaks it down into specific uh, titles for each individual part. For instance, the smallest atomic molecule is something like a module, and a module can be something as easy as sending a ping command through Ansible. Outside of that module, you can add multiple different modules and combine that within a task. This could be something like copying a file over to a operating system and then running it on that operating system. So that's two different modules combined within a task. And those tasks then build up into a playbook. And that playbook runs against a group of endpoints and configures them to a specific state and standard. And so that all kind of allows you to kind of start small, learn a little bit more about the modules, and then grow from that and say, okay, this is what I really want to do within my specific group of endpoints. Moving out of Ansible engine or Ansible's open source solution, and let's jump into Ansible Tower. Ansible Tower gives you really the solutions in order to take this into an enterprise environment. You really don't want to run Ansible open source in an enterprise environment because it can lead to a number of different issues. One of them is who ran what when. And this is can be a real big stumbling block when you're looking at standardizing your environment, because a lot of times you'll standardize a group of endpoints or servers or what have you, and then you'll see that drift start where that standard is set, but these machines over here all of a sudden are not keeping that standard. And what's happening and who's running that, right? By using Ansible Tower, you actually have the analytics to show you what's actually being ran from Tower. So if you have some standardization drift, you can easily see whether Ansible Tower is doing it or something else is doing it. Also, Ansible Tower gives you the versatility to see who's running specific things. So if someone's running something that's not within, a change advisory, then you can go back to that person, find out why, get some information, and it just allows a lot cleaner workflow of the automation tool itself. Ansible Tower allows you to connect to CI/CD for your Ansible code repository. I don't know about many of you, but myself, I am dependent on my IDE. I use VS Code for myself, and the built-in linters and things of that nature just make my life so much easier. Having the ability to take that code base and then push it into a Git repository, whatever that may be, and then pull that into Ansible Tower is extremely usable and much, much easier to handle, especially for someone like me that's not very good with the basic OS text editors. Ansible Tower also comes with a versatile and well-documented REST API, and I want to stress it's it's fully documented. And the reason why I stress that is because if you've played with REST APIs, you know how that extensibility can build into multiple different tools working together to create a seamless solution for the environment. That's extremely powerful. That's a great solution that Ansible Tower brings to the table. And finally, role-based access control within Ansible Tower allows you the versatility to say these people have access to these playbooks, these people have access to a different playbooks, for instance, and then segregating those groups. So you have your maybe a operations team, a developer team, and then you can separate those guys from which playbooks they're able to run, which endpoints they're able to run against, things of that nature. So that's a little bit about Ansible and Engine and Ansible Tower. Now the question is, well, what can I do with Ansible? It's a well stated statement, I guess. A lot of people have said this before. And I'll again say it that you can do almost anything with Ansible. There is a huge amount of modules that are out there. It is a large community that is well behind it. And there are so many different connections that you can make to so many different things. But just to give a high level of what different things you can do with it. You can connect Ansible into your CI/CD. So this is a little bit different from what I was mentioning earlier in terms of CI/CD, because that was continuous integration and delivery into your Ansible playbooks themselves. This is more the continuous integration and delivery into your actual code base. So you can actually take Ansible and combine it with Jenkins if you're using it for your CI/CD pipelines, and use those modules and playbooks within that pipeline. Next is provisioning. This is a really big deal and really awesome for anyone that's used code in order to provision things. It allows you to provision into virtualized hypervisors. It allows you to provision networking components, storage components, as well as a lot of different things within the public cloud. These solutions are very versatile and very powerful for us to use. I like to kind of combine configuration and application deployment many times, because if you're setting a standard for your solution, for your environment within configuration management, normally app deployment is part of it. But let's separate those out, because you could actually have a operations playbook that's specific to configuration management and have a completely different playbook that's specific to application deployment. And you could combine those together, right? So let's take these two and kind of separate them in terms of the configuration management of verifying each key component on the endpoints is set to the standard and policies that you want to keep it at. Everything is installed exactly where it needs to be. And then, moving into the additional of app deployment, installing the applications that are necessary for that infrastructure to run on that infrastructure and maintain that application in a good state. Finally, in terms of security and compliance, you've heard me say it, a number of times at this point, but when we talk about standards and practices, that normally follows within the security and compliance of making sure that your environment is secure, making sure that everything is compliant with the standards that you have, and keeping those things running as you go from the day to day. Now I'm going to pass it over to Billy Downing, who's going to walk us through Ansible's integration with Cisco and the demonstration. Billy?
Yeah, awesome. Thank you, Nathan. I appreciate that. My name is Billy Downing. I'm also a cloud architect here at Sterling on our strategic services team. And kind of what we're talking about here is I'm just going to make this a little more specific as far as what Ansible is and how you can use it in a Cisco-based environment. So first of all, as Nathan was talking about the different modules and different collections that are involved within Ansible, what we can do is use Ansible as a platform to abstract all of our different devices in our distributed architecture, because as we know, most network topologies are made up of distributed control planes, which sometimes makes it a little more difficult to manage and track the configuration of those separate nodes within a large network fabric. So what Ansible is doing is allowing us to abstract that entire distributed architecture of our network as it stands, and build in a centralized control point that we can use to configure and manage all of those different devices using a common language across a common language in YAML across all the different devices. So incorporating that network infrastructure into a DevOps pipeline is referring to what Nathan was talking about in defining all of your different playbooks and your network configuration in Ansible-based playbooks and located in a Git repository. So what that means is that as you are developing your applications, you can link the application deployment to the deployment of specified playbooks in your network fabric, so that as you're developing applications, you're developing your network to support the applications right along with it. What I mean by that is if you have a Git repository or several Git repositories where you're developing and pushing your application code, the operations folks or whoever is managing the network itself can work with the development team to go ahead and ensure that the playbooks or the configuration state of the network matches the application requirements. That could be things as simple as enabling data center specific features, enabling OSPF features, enabling packet captures, things like that you can do just to work alongside your application developer peers to ensure that your application or your network rather supports their application in a programmatic way. And you can store all that information in a simple repository and then version control that so that you're aware as the application moves through iterations in code as they go through those development pipelines. Your network configuration is going through those same pipelines, so you know the version of application compared to the version of network configuration at the time. So for programmatic network configuration, kind of this isn't just for SSHing into boxes and making configuration changes on them through that means. This can also be used across the entire plethora of Cisco products. So this isn't specific to routers and switches running iOS XE. However, that is what we're going to be demoing later on. But this also includes if you have a UCS chassis within Cisco, or you're using Cisco ACI and you want to be able to interact with that ACI API endpoint, you're able to do that through Ansible. So it's not just SSHing into your boxes and banging out configurations through Jinja templates. You're really able to do this with a programmatic access method. If you so choose and you have not a non-homogeneous environment and you want to standardize your network configuration using the Yang data models and you are using netconf to actually invoke those configurations, Ansible can also do that as well. So rather than using API access directly or SSH, you can also use a netconf connection and send your configurations in XML using Yang data modeling techniques, if that's your cup of tea as far as your network configuration. So as Nathan mentioned as well, for compliance and remediation, what Ansible Tower specifically brings to the table is the ability to schedule in an intelligent way, schedule playbooks that can run at specific intervals onto your devices. Because these playbooks are idempotent, meaning that when Ansible is going to run against the devices it's trying to configure, it'll first understand the state of that device and then understand the differences between the state of the device as it sits and the state of the playbook that you're trying to apply to the device. What that means is if you were to run, say, for example, you had a specific IP address that you needed to be assigned to an interface on a network router, you can go ahead and put that in your playbook. And if you were to run that playbook 100 times, it would never alter the IP address from the original state of what you're intending to be. So what that means is if someone goes into that device and does an unauthorized change where they change it directly on the control plane of the box itself, as soon as that Ansible playbook runs again, it'll change it right back to the known good state that you can use to kind of understand your environment. So what that does is provide you with a single source of truth inside of your Git repository where all of your playbooks sit. And that is something that you can use as an auditing technique as you're going to any sort of process remediation or security audit for your environment. You can point to your source of truth, lock down the control plane of the boxes themselves, and go ahead and use that as your starting point for auditing the environment for any sort of security vulnerabilities or configuration state as it stands. The last one that is very specific to Ansible Tower, another benefit of that is that role-based access control, as Nathan mentioned, and we're going to take a look at how this hierarchy is actually built out in Ansible Tower using organizations, teams, and users through LDAP control and how we can actually allow certain users to do to invoke certain templates, a part of certain projects, and all of that good stuff. So the terminology can get a little murky, but I'll go ahead and show this in the UI, and I think it'll make a lot more sense. So with that, I'm going to go ahead and share my screen and show you the UI for Tower, and we're going to go through a demonstration. Okay, perfect. So what we're looking at now is the dashboard for Ansible Tower. So this is the kind of the focal point or the UI that you'll be utilizing in Ansible automation platform scenario. And this is something that you don't necessarily have to use the UI if you don't want to. There's also an API that you can interact with, and you can do anything you can do in the UI, you can do through the API as well, if you are going for a complete infrastructure as code type deployment. So first, we'll talk about the different organizations or the different methods of organizing users and access permissions within Ansible Tower. And first, we're going to start out with organizations. So this is the highest level of organization when it comes to placement of workbooks, placement of users and teams. So we see here that I have the default one as well as a Sterling organization. In that Sterling organization, I have a few inventories assigned to it, job templates, projects, and different teams. And so what this really allows me to do is create different subsections of organizations for different teams that are utilizing Ansible. This can be really helpful if, as Nathan mentioned again, Ansible is not just a single-use tool for a specific product set. The way that Ansible is built out in this modular fashion, using collections and all those different sorts of modular components to configure your different aspects of your data center or any other component. You can have a different organization built out for permissions for your data center. If you have a Nexus fabric or an ACI fabric and you have specific administrators that want to automate functions within there, you can have a separate organization for your or a separate team within the same organization for your server control. So if you have Linux administrators that do specific configurations to their Linux boxes, or the same thing for Windows, and that goes into the rest of the Cisco portfolio as well. If you're doing VipTele SD-WAN, you can use Ansible to automate that as well. ACI, iOS XE, UCS, all of the different platforms you can put under a single umbrella in Ansible Tower, and then divvy out permissions to actually invoke actions on those different assets using RBAC through LDAP connections or however you're doing identity verification in your environment. So within here, we have a pretty small environment. So we just have an automation team, which Nathan and I are part of in this organization. And we also have a server team just to show that differentiation between teams within the same organization, where then you can attach permissions to. So what is the actual framework of what we're setting up and how we're actually going to be doing this? So first thing that Ansible needs to be aware of is an inventory. So it needs to be aware of what devices is it attempting to configure in this environment. So in my environment, I have a very specific or a very small sample set of Cisco IOXE devices that I'll be demonstrating configuration against. Here's where we can talk about those permissions. So who has permissions to control this? And from here, I can divvy this out to team roles if I need. So if I have a specific team for automation or say networking, I can go ahead and give them that role over this rather than having to do granular permissions, giving out permissions to specific users. From this inventory list, I can go through and create all of my hosts that are going to be built out in this. I'm just using basic IP addresses, and within these IP addresses, I'm giving them certain names, so the description of what these devices are. And then within that, I have specific groups that call out what these devices actually are. So their entire subgroup is going to be the iOS XE group, and then they're broken out into role-based, role-specific based configurations dependent on what their use case is going to be. You can also do dynamic inventories as well, where it's pulling different sources for the assets as you're deploying upon it. So for example, if you have a virtualized Cisco environment where you're using ASAVs or other virtual components, and so you're running on a whether that's OpenStack or whatever virtualization technique you're doing, you can use Ansible to dynamically pull that entity that is managing those assets to then pull in the information for the hosts themselves. So you don't have to manually go ahead and do this every time for each host. A way that I've seen devices get added into this previously. So if you're talking about day zero operations and you want Ansible to configure your devices as soon as they're plugged into the network, what I've seen before with customers doing is when they're ordering devices from the factory, you can obtain the MAC address for the management Ethernet NIC that you want to use. Then you can go ahead and use, I know that DHCP on a network fabric is usually frowned upon, but I think in more modern solutions, it's becoming more and more accepted to go ahead and pre-allocate IP addresses based on MAC addresses, so that what you can do is as soon as you plug that device into your network, Ansible is aware of that device. The DHCP will allocate the correct IP address based on the MAC address of your network component. And then Ansible can go right ahead and start configuring that device the moment that it's connected to the environment. So that's really beneficial to understand as your environment grows and scales, that you don't have to worry about maintaining all of these separate templates and these separate configurations that are very nuanced per device. The goal here is to treat your distributed network fabric as a more like cattle rather than each device having this snowflake pet-like configuration. So we have our inventory. So we have what is Ansible trying to configure, and we have these three devices. The next step is what are we going to configure on these devices? And so what I have here is what's referred to as a project. And what this project is really doing, and this is one of that part that disaggregates the configuration of your environment away from the management node that's actually doing it. And so I have a GitLab repository where I have all of my playbooks stored. So this project simply goes through and it goes through and grabs all of the contents of my Git repository. And from that, it can glean and pull in the different playbooks that I have. So I see here I have this URL, and it's going to be pulling this in from my actual project. So if I look at my GitLab repository, I can see that I have a few different playbooks that are in here. They're going to be pulled into my Ansible Tower environment, and then through integrations with Red Hat and Cisco, there's different modules and collections that are involved in here. And then Ansible Tower is going to take that and then deploy that to the inventory host that I specified. So now that I have my playbooks written, so I have a playbook just for my baseline, I have a playbook for my core specific configurations, and then for my spoke configurations as well. So this is a very simple kind of outlook of how you can monitor and manage your different configuration assets based on roles of your environment. There are different ways to abstract away the playbooks away from the specific nodes that you're trying to configure. And you can go into things like developing roles using Jinja script or Jinja templating engine and all of that good stuff. But I wanted to keep it really simple for this just because this is a shorter demo and we want to just get the point across. So the idea is I'm bringing in all of my configuration into Ansible Tower from a Git repository. Every time I want to change my infrastructure, I don't have to log into the device itself. I simply change my templates, I commit my code to GitLab, and now that version iteration is kept safe and restorable if I should make a mistake and need to roll back configuration changes. So now you have a programmatic way of configuring your devices rather than jumping in there and hand jamming configurations into a box and having those configurations go live the moment you hit enter. You have the ability to actually go through a configuration review process if that's something you want to do. So rather than having to, I'm not sure how common this is anymore, but having to submit your actual iOS configurations or your ACI configurations in a Word document up to a CAB board for, perhaps a bunch of individuals who are directors and leads and things like that who don't necessarily understand the configurations. They're there to just approve the change based on whatever mechanism. Now you can use GitLab and you can use a more programmatic way to have other engineers review your work and approve it before it's actually merged into the master branch that is then pulled into Ansible Tower. I'm only using the master branch, but you can see here that you can specify branches and tags or commit hashes as you go through to ensure that that process is followed. As you're making changes to your Git repository or your configuration templates and playbooks, you can have that review process. And then you can have the final, once you merge that request into the final branch, it'll be pulled into Ansible Tower for actually configuring your devices. Okay, so we have our inventory. We know what we're going to configure. We have our projects. We know how we're going to configure it. But now we need to know what are the different components of how we actually access that device and what are the different ideas of which devices are where and all that good stuff. So how do we tie this all together? So first, I guess before I do that, I'll jump into credentials. So how do we log into these things? So Ansible, using Vault and other techniques, you can also pull these in from different kinds. But we see here that I have a very generic machine credential for my Cisco devices. In my environment, all of my Cisco devices use the same credentials. But essentially what this is doing is giving me a way to store my credentials so that I don't have to keep them in plain text in my Git repository inside of my my actual playbooks themselves. So this just gives me a way to remove and abstract credentialed information or sensitive information out of the configuration playbooks themselves and into a little more safekeeping environment. Okay, so templates. This is how I'm going to pull everything together. So what I'm doing with my templates here is I'm creating what are called jobs. Each one of these jobs is associated with a project. So I'll take a look at this day zero baseline. So I have this project, and then this is where I'm going to tie everything together. So what inventory does this project relate to? It's going to be my Cisco lab. So now I know what hosts I'm actually going to be configuring. What project am I going to be using for this? It's going to be that Cisco lab demo, which is pulling in all of my playbooks from my Git repository. And then from there, it dynamically grabs all the different playbooks that it discovers inside of your Git repository from your project. And then you can choose based on job, which playbook you want to actually run here. From here, there's a lot of different configuration metrics you can use. You can add different variables. You can do all of that good stuff that you need to do that are specific to your environment. This is also where you can assign notifications or permissions based on teams again, or based on specific users as to who can actually invoke this template, who can actually run this job. We also have notifications. So I'll see here that I have, in some of these things, I have Slack notifications set up just as an example of how this would work. And also we have what I was referring to earlier as the scheduling of this to ensure that you avoid configuration drift in your environment. I don't have configuration for this setup on this environment, but this is something you can do if you want to run something, for example, a backup job or some sort of a configuration that's very simple that goes out and saves all your devices once a night or multiple times a day, or something that verifies that all the configuration from a security admin perspective are all applied every day, so that you don't worry about your engineers going out there to disable certain features while they're troubleshooting, and then not going back and fixing those. You can have something run once a day to ensure that the configuration matches what is in your Git repository, so that you can use that as a definitive source of truth. Again, so we have all of our jobs here. So each one of these jobs are contained from a single playbook that I have written. But then I want to be able to, string those together. I don't want to have to, when I deploy something, run this job and then run another job and then run a third job. So that's when we start using workflows. So if I look at this workflow, what essentially I'm doing is now I'm tying together all of the different playbooks or all the different templates that I have as individuals and tying them into a single runbook. So with this, I'm able to do an if-then statement based on playbooks. So I can link playbooks in order of how they need to be configured. And I can say, if this playbook fails, do X. If it passes, do Y. Or I can say, in this instance where I have, no matter what the result of this one, do the next one. No matter what the result of this one, do the next one. And this could be something that if you're trying to develop a DevOps pipeline using Ansible Tower, for that deployment aspect of this, you can tie workflows into different aspects of your environment. So in this workflow, you can have jobs that are specific to your Cisco environment to configure alongside the application. So you can have a job here that is your day zero baseline for your Cisco environment. Then you can have another job that runs simultaneously that's running on your server infrastructure to ensure, say, your virtualization platform, or if it's something like a containerization platform and you're trying to provide certain networking capabilities like network policies or things like that that are specific to your application, but is down outside of the physical network itself. Day two, or the second step, can be if all of those first ones pass, you have X happen, and if it fails, you can do a rollback mechanism as well. So workflows are just a way that allows us to string together all of our jobs and all of our playbooks in a way that we can automate an if-then statement process for how we're deploying configurations in our environment. So I'm going to go ahead and run this in just a second, but I wanted to show you this, one of the devices that I have running up. So I'm going to log into one of the core devices. And I'm just going to show you that, there's nothing really configured on it just yet. So I have a host name. If I show my IP addresses, I just have my management IP address. And then if I do something like check out my OSPF configurations, I see that I have nothing here. So what my playbooks are actually going to do, and this is a very simple example, I'm going to configure a day zero baseline, which is going to put things like a banner on there. It's going to configure logging settings, NTP, domain settings, things like that. Then it's going to have a day two core. So after my baseline is set up, my security policies are built out, my ACLs, everything that I expect to have on every device is applied. Then I'm going to go ahead and run through my workflow, my core specific device configuration. So on my core, I might have different ways of configuring layer 3 interfaces. I might have different ways of configuring OSPF. In this instance, I'll be configuring a layer 3 interface with OSPF and enabling some other features in the environment. And the same thing for spokes, because you might have different configurations for your spoke environment. But the goal here, and this could be more probably aptly named as leaf spine. I'm not sure I just went with the core spoke terminology, but think of it as a leaf spine environment where you want those different things to be standardized. You want the same interfaces to be configured the same way on each one of your devices. So you're treating your network fabric like cattle rather than like unique pets. And so what this is doing is just giving me the ability to break down my playbooks to have role-specific applications based on the role that my network fabric is actually playing. So I have leaf nodes, I'm calling them here spokes, but I have leaf nodes that are configured a certain way, core nodes that are configured a certain way, but all of them still have the same baseline. And my workflow is going to go ahead and take care of that. So what I'll do is I'll just kick this off. Again, this can be scheduled. This can be done manually. It can be done invoking through the Ansible Tower AWX API, however you see that fit. So once I go ahead and kick this off, we can see that it's going to go ahead and go through my workflow. So the first step is going to configure those day zero baselines. And then it's going to, once that completes, it's going to go ahead and hop to the next step, which is going to be configuring my core specific configurations in my environment, and then my spoke specific configurations. So we can see this one finished, and then let's look at the details as we see this one running. So as we see this running, we can actually see specifically what Ansible is going out and doing, what devices is actually touching, and if it's changing them or not, or what's going on with it. So we can see that Ansible went out, it checked my device to see if the playbook or the state of configuration that I'm attempting to configure on the device is already there or not. So it determined that the device that I'm interacting with was not configured to the state of my playbook. So therefore it needed to be changed. So if I were to run this playbook again directly afterwards, so if we just go ahead and do that. So if I run the same exact playbook again, because this is idempotent, I don't have to worry about this breaking anything. I know that it already applied successfully. So if I run this again, it'll just show that nothing was changed because everything was already at the state that I'd expected it to be. So if I go here now, I see that nothing was actually changed, even though I ran that playbook for a second time. That's just to highlight that idempotent aspect of it as it's going through the environment. So if I look at my jobs, I can see that all of my jobs ran here. And I did have this set up with notifications. So if you are using something, or you can set up email notifications, you can set up Slack notifications. In my case, I set Slack notifications. So I can see here, as I ran this environment, I was getting notifications sent to a specific channel of all of the successes and failures of that as it went through the entire pipeline. So if you are a team and you're looking at how to enable something like chat ops in your environment, or you have some sort of central way where all your engineers are talking and discussing, and some sort of platform you use for that, you can use Ansible Tower to send notifications to that platform. So you're always aware, everyone at least is always aware when jobs are running, when jobs are failing, and all of everything that goes along with the status of jobs as they go through the environment. So what that allows you to do is you're bringing in you're abstracting away the network fabric from a distributed control plane architecture. You're bringing in Ansible Tower to abstract all those unique configurations, build templates and templates for those environments based on roles, apply those, and then get notified when the application of those configurations works or does not work. So if we go back over here, we can see that all works successfully. So let's go ahead and check out my environment. So I'm still logged into this core. Let's check out my OSPF configuration. So now I have my OSPF configuration. So let's see if I have any neighbors. So now I have neighbors. So I can see that my other two nodes are configured with their IP addresses as I expected. So IP address .101 and 102. And they are now peers with this environment. So before I went from having 0 OSPF configuration on any of the boxes to now all of my boxes are running OSPF, they're configured together, their interface IP address is up, and all of that good stuff that goes wrong with that. So now the state of my environment as it sits now, I know is held in a Git repository, and everything is exactly as I would expect. So just to show an example, if I were to go into this environment and say I were to change this IP address, so I would start skewing from the states of what Ansible is expecting, or what I, as the administrator, am expecting. So say I go in here and I just break this IP address. So this could be a change that's going to break my environment. So now that has changed. Now I have an issue. No one knows what the change was, or who did what or why, if you don't have on-box logging enabled. So to fix this, I can say, you know what, I know that my previous state was successful. So I can go ahead and run, because I've broken this out on role-specific jobs, I can run this day 2 core again. I'll go ahead and run this, and this is going to put it back to the state that I should be expecting in my environment. And this can be not just for IP addresses or something that's a breaking change, but this is most commonly seen in environments where you can see that if you're troubleshooting something and perhaps you want to change out your ACLs because you're trying to troubleshoot traffic flows in your environment. What you can go ahead and do, if you're in the heat of troubleshooting, you maybe put a allow any at the bottom of an ACL and you kind of open it all the way up. You fix your issue, but a lot of times you forget to go back and change that ACL. So now when you're being asked, is your network compliant to the security protocols or security procedures that we have set in place? You'll be like, yeah, it probably is, but you're not actually totally sure of it because maybe someone went in there and troubleshooting and forgot to change it back. So you can use Ansible to run on a scheduled basis to ensure that configuration drift doesn't occur. So we can see here that there was a difference in the configured interface. I can see the actual specific code that it sent out to it. So you can have all of this as variables. So this is showing what is actually, so in my template, I have variables set up. This is showing what was actually applied to the environment. So I can see what should have been there, what was there, and how I should change it to get to the state that I need to be in. So if I go look back at my device, I see that previously I had changed that. But if I go back through, I didn't have to log in again. It changed it back to the state that I'm aware of from an Ansible perspective. So now my source of truth is, again, the source of truth. And if I run this on a schedule, I know that it's going to be applied every single day in an idempotent way to know that the network fabric is configured exactly as I expect. And again, all those notifications were sent out as that job was running. And we can see that it was successful in our Slack channel or whatever means of notifications you're looking for in your environment. So from there, I mean, there's a little more aspect from managing your environment using Ansible, and this is more of a administrative perspective of how many hosts you're running, failed host inventories, all that good stuff. And what you're actually doing is from an auditing perspective. So you can see who did what, when, and why they did it. I mean, not necessarily why they did it, but you can see exactly what roles they're applying, when they're applying it, and who is doing it. So it's just a very helpful way to audit changes in your environment, all from the same UI that's actually configuring the environment. So rather than having a third-party auditing service that is going to be, that is not necessarily sure of the state of the environment, you can use a tool like Ansible Tower to ensure that the state of the environment is as you expect, and you know who created that state for the environment. So with that, I don't have anything else. So I guess if there are any questions in the chat, we can go ahead and handle those. But if not, I want to thank everybody for joining, and I appreciate you taking the time.
Hi, Billy. We actually do not have any questions in the chat right now. So I really appreciate everybody attending and joining us today. Feel free to reach out to Sterling at connect@sterling.com if you have any future questions. Thank you so much.